Okay. Again, you can use your calculator to graph these. You type them in and look at the table for the symmetry. But here are the first two. Y equals x squared plus 3 is here. It's got a vertex of 0, 3. And it starts off low and then starts to climb higher and higher with the axis of symmetry being the y-axis. Here's y is equal to absolute value of x plus 3. Again, it's raises up. And has a same vertex. They do intersect here, but it looks like that. Notice it doesn't look like mine has a slope of 1 here, but it does because I'm counting by, every other for 1's here, and here I'm counting by exactly 1's, 1, 2, 3. But that's what it looks like. How are they alike? They have the same vertex. They have the same axis of symmetry. They both open up. Different. One's straight and the other one's curved. They have different points, obviously, except for these three. And then the parabola is below the absolute value from -1 to 1, except for this point, and then above otherwise. So basically, notice here when the oops, I actually wrote this wrong. This should be like this. Sorry, the absolute value should be outside of the x. So we basically have the x squared graph being raised up by 3 here, whereas the basic absolute value graph being raised up by 3, and we get the predictable result here. On the bottom here, we have y is equal to 2 times the quantity x minus 2 squared, and down here we have y equals 2 times the absolute value of x minus 2 squared. So again, we're taking the basic graph, y equals x squared, we're shifting it right 2, and then we're making it more narrow by 2. Whereas here, we're taking the basic absolute value graph and shifting it to the right 2, and then multiplying it by 2 to make it more narrow. So the graphs look like this. The like and differences are very similar, same vertex, same axis of symmetry. They both open up. They're very similar in that regard. One's curved, the other one's straight, but that's that.